you don't know about Real Good AI, you should check out the link in chat. You should check out the website. But joined today by members of the Real Good team, Dr. Emin. Oh no, I've committed to saying your last name, but I don't remember how. Gormiri. Dr. Emin is here. How about that? And Dr. Mandy, regular Craig, regular Bob,
Yep.
and our special guest for today is Dr. Lori Tunstall, who is a associate professor.
Assistant.
Assistant, man.
You know,
So close. I have notes. I could look at my notes, but who does
that's
that?
okay.
You
We're just looking ahead to the good things to come.
know? Anyway, assistant professor at the Colorado. Now I'm second guessing everything. Assistant professor at the Colorado School of Mines, Civil and Engineering Department, and Civil and Environmental Engineering Department. That's a lot of words. Anyway, thank you so much, Dr. Tunstall, for being here. And we're going to be playing Minecraft, chat. I'm going to put that up on screen. But while we play Minecraft, we're going to talk to, should I call you Lori or Dr. Tunstall?
Lori, please.
We're going to talk to Lori about her work, her research, what she's done, what she's doing, and maybe some AI stuff too, since this is a real good stream. But we'll get to all that. I'm going to respawn and hope we don't die. I know we should get to the interviewing and to the introducing, but yeah, I think maybe we should focus for a second on making a house, getting some implements.
Yeah, I was going down
dying on repeat
to get wood so that we could make a crafting table, right?
Which way?
I thought she seemed safe.
She down here somewhere?
No,
You
I'm
remember?
not the safe one. Bob is the safe one.
I'm about to die to a creeper, so
Oh, me too.
Do you remember which direction she went?
Oh,
never mind. Okay. Ow. Oh, that's a creeper. All right. Hello.
All right. There's
follow me. Let's gather the crew here. Craig, come with us. Mandy, come with us.
I'm coming.
Oh Lord. We're gonna go down the hill over here. What we really need is trees at the moment. We're gonna go down this way. I'm gonna go to the right here and hopefully get some wood really quickly.
We're getting zombied.
It'll be fine. It'll be fine. It'll be fine.
Oh no.
Is everyone dying?
I'm
I hear zombies doing something horrible to someone. Oh
no, Lord. I was punching him.
It was me. I died.
Stop.
I'm following.
Okay, so can we ask some questions?
Go ahead. Yes.
Busy right now?
Yeah, we're fighting off a bunch of zombies, but yes, questions.
Yeah, so Lori, hi and welcome to our
Thank you.
So I just wanted to ask, like, the first question is, like, can you briefly explain your research as an assistant professor at the university? So briefly, what do you do? You're a material scientist, so, and specifically you're specialized in cement and concrete. So can you explain what do you do?
Yeah, sure. So my research is all focused on improving concrete durability and sustainability. And we do that using material science. So understanding the fundamentals of how the process structure. Wow, this is really taking multitasking to a new level. Can you fight off zombies and have an intelligent discussion? I don't know. We'll try.
Yeah, that's your challenge. Yeah.
And so we're understanding how material processing works to impact the structure of materials and how that ultimately affects the performance. And right now, my research is primarily focused on incorporating a material called biochar into concrete. Biochar is a carbon negative material produced by heating a biomass material in a limited oxygen environment. And basically what that does is, typically you have a biomass material like a tree or even can be something like manure. And when it decomposes, it releases CO2 back into the atmosphere or sometimes methane. anyway, these greenhouse gas emissions that we're trying to avoid releasing. And by pyrolyzing, so that heating in a limited oxygen environment, you lock in those gases that would otherwise be emitted. Um,
How do you do that? How do you in a zero oxygen chambers or something? How do you do this process?
yeah, so sometimes it'll be under nitrogen flow, and sometimes it's really just in like a closed container that doesn't have access to continual oxygen streams. So just something that is closed off from the atmosphere. So it doesn't have to be sophisticated. There's all sorts of equipment. The most sophisticated are equipment that not only pyrolyzes the biomass, but um, also like collects things like vapors and oils that can be upgraded for fuels. So wow, this is so hard to do multitasking.
We should
Uh,
be safe for the minute. I turned it to so you could talk without us being in
So
imminent
let
peril.
me break a little bit down what you said. So basically, so first cement and concrete. What's the main? What is it actually? Can you explain what is concrete? What is cement made from?
Yeah, yeah, that's a great starting place because a lot of people use cement and concrete interchangeably, but they're not. So cement is the powder that interacts with water, so it reacts with water. It's the material that binds all of the aggregates together. So I say like if you think about a cake, the concrete is the cake and the cement is the flour. So it's just one ingredient in the concrete. So concrete is made of the cement powder, water, and then the aggregate. So sand and coarse aggregate like rocks. And the cement is really the engineered product. That's the one that is really tightly controlled, and it is, as I said, the glue that binds everything together. So that's the one that's really like engineered, and the other ones are mined products or water. What we're
And
doing
the
is
whole product is the concrete.
the right. Well, so like our what we're focused on several things, but
Mhm.
to start, biochar is a pretty verse is a pretty diverse material, so it can be really variable depending on what the feedstock is, how it's processed. So one of the things we've been focused on is how do different characteristics of the biochar impact the cement composition or the cement composite? So like mortars or concrete. I'm going to use mortars and concrete kind of interchangeably. The only difference is that mortars are like cement, sand, and water, and aggregate is cement, sand, and water plus. I mean, sorry, concrete is cement, sand, and water plus coarse aggregate. So anyway, we're looking at how the biochar characteristics impact the cement composite. So once we understand that, then we're looking at how to control the biochar characteristics to optimize the performance in concrete in a cementitious composite. So it's
So
really like a very fundamental materials science
okay.
problem. We're trying to understand how the biochar characteristics affect the concrete composite, and then um, how we can tune the biochar characteristics to optimize the performance in concrete. And the
So
reason why
yeah, I was going to say the reason why do you want to optimize the concrete here? For what?
okay, there's a few problems. So one, concrete has a massive carbon footprint. So it's responsible for about 8% of global CO2 emissions. That's equivalent to all passenger vehicles on the planet today. So it's a huge impact environmentally. And so if we can,
And how come? Sorry, how come? Because like
yeah,
people envision a car polluting, okay, but how concrete is has this environmental impact? How?
so it's tied to the cement itself. So to make cement, one of the main ingredients to making cement is you take limestone, which is calcium carbonate, and you heat it to make it reactive, to make it the calcium oxide. And when you heat it, so you're taking calcium carbonate, converting it to calcium oxide, you kick off CO2. So that's one of the reasons why it's considered a hard to abate industry because it's tied to the material properties itself. To make cement, you have to convert limestone to calcium oxide, and in that conversion, you're releasing CO2. So to offset that, we're looking at, there's a lot of people that are tackling this problem in different ways. Some people are trying to make totally different cement formulations. So okay, let's let go of the limestone formulations because that's problematic, and let's move to a totally different formulations. My group's philosophy is, I'm glad people are looking at that, but I think that's going to be an upward battle, because an uphill battle, because we've got all of this data for this limestone based cement, and so if we start trying to
From
create
scratch,
new types of
basically. Yeah.
cements,
Mm,
it's just we don't have all the historic data. It's going to be a challenge.
I see.
Um, and so our philosophy is let's stick with the conventional cements that we're used to, and then and then um, offset it by incorporating a carbon negative material, and that's why we were looking at biochar. And so um, now
So,
we
can you
the
describe what
yeah, go ahead.
carbon negative means?
Sorry, we couldn't hear you.
Oh,
Yeah,
sorry. Can you describe what carbon negative
Yeah.
material means?
yeah, that's a good question too. It's kind of a weird concept. So because you're avoiding the release of CO2 back into the atmosphere during the biomass decomposition, it's biochar is considered a carbon negative material because of that avoidance. So instead of the biomass decomposing, releasing the CO2, now you've got it trapped into this really stable form, that is stable for centuries, if not thousands of years. And so it's considered carbon negative because of that avoidance. Now we're not getting it to decompose and release back into the atmosphere. Does that make sense?
Yeah. So basically, the sequestration of this CO2 makes it negative instead of like releasing it. That's what you're saying.
Yeah, exactly. Yeah,
I
so
see.
the biomass itself, so imagine, a tree, right? It's taking on CO2 during its
Mhm,
lifetime.
mhm.
Now say you have, forest residues. So some of the branches, or you have trees falling, and over time that'll decompose and it'll release the CO2 back into the atmosphere. We're basically circumventing that process. So we're letting the biomass take on the CO2 during its life, and
Mm,
then we're cutting off the decomposition source. And so now we're locking it into this stable carbon form.
I see. I want to come back to the 8% of the carbon emission. You said like the concrete and like industry release that. For me, it's crazy. Like, why? Like, how? Like, is it because when I see in the US, most houses are built with wood. They
Yeah.
don't use concrete. So where is this concrete in?
We use a lot of concrete though. In the US is a lot smaller of the global population, believe it or not, in terms of cement consumption. I want to say
Mhm.
we're about 3% of global cement consumption. Most of it is in China and India right now. And that's just because of the rapid urbanization that's happening. Um, so, and that's really the problem isn't how uh, how the high carbon impact of the cement itself necessarily. I mean, it's really because we use so much of it. So,
Like,
per
how much
unit
use
mass, the cement's not that bad, but we use so much of it.
for like you mean residential, commercial building, everything? Like, what is the most?
What are we using it for?
Mhm.
Yeah, there's a lot of like really high structural applications. So like high-rise buildings, they'll be in the foundation, they'll be in the beams, they'll be in the columns, they'll be in the floor slabs. A lot of people use it for roadways. Yeah, I mean concrete's used for everything. Dams.
Yeah, yeah, sure.
Yeah,
Infrastructure.
you know, most infrastructure is interfacing
Mhm.
with concrete. Wow, you guys are really busy with a
So
lot of
I'm
stuff.
reading a question, a follow-up question from the chat. So
Yeah.
we said, is there still limestone in this mixture? the biochar thing, or it's
There
just the way you're heating it causing this change in behavior?
Yeah, good question. So we're still using conventional cement. So remember, our philosophy is we're going to have a really hard time convincing the industry not to use, to use a different cement. And our philosophy is let's just try to minimize the usage of the cement and then incorporate a carbon negative material to help offset it. And so now we've demonstrated that we can replace upwards of 50% of the cement and concrete with a biochar based material. And that gets us to carbon neutral embodiments for the concrete itself. So it still is a limestone based cement, but we're using less of the cement and then we're replacing it with a carbon negative material. So the net effect for the concrete can be carbon neutral. I'll also show this is kind of an example of what it looks like. It's a different color. So if this is, more like conventional
Hmm.
great color, right? This is what everyone's kind of used to seeing.
Mhm.
And this is
Ooh,
like a carbon neutral
pretty.
uh cement mortar with biochar. Yeah. So this is carbon negative actually. Um and we've demonstrated that we can get the same sorts of strength with the right controls. And that's, Iman, you were asking about, why worry about optimization in concrete. And that's really why we want to be able to incorporate as much of the biochar as possible into the concrete so that we can make it carbon neutral. Um,
Yeah.
but to do that, we and tune how the material works in concrete so that we can maximize our carbon impact. And since it's a variable product, depending on the biomass that you're using, then we need to understand how to kind of modify the feedstocks that are available, and the pyrolysis conditions so that we can get good performance for locally sourced biochar. Of course, if you're shipping it across the country, then you're going to kill the carbon footprint. That's not
Yeah.
the
What type of you said manure and things like that. How do you get them? Where do you get them from? Like farmers?
Yeah, I've gotten contacted by so many different people doing different sources, making different sources of biochar. So really, any biomass you can think of can be used. Um, and
Interesting.
yeah, it's getting dark. Is this you guys? Look at you! You made a little
This
shelter.
this house should be safe. I'm about to come put a bunch of torches on it, and light should prevent mobs from spawning inside. They might still attack it, but and actually we don't have windows, so they might be able to shoot like arrows through it.
Through
It
it.
should be relatively safe.
Wow, I'm so impressed.
Oh, hey, look, a zombie. Ah.
Ah, shut the door.
So
I also tried to give everyone a diamond a sword. I may have cheated a little bit, but if you have
Oh,
a
I
sword,
saw
you can
that.
equip that and that'll kill things really effectively.
Okay, cool.
So I feel we have an expert in the chat that is interested into this thing. So I'm going to ask their question. So conventional raw meal, I imagine it would be hard to change. What they said, like, do you think with enough time we might be able to change over to a safer raw meal, whatever it means, for our future cement production?
Yeah, and there are people looking at that. I think that's okay. That I have complicated feelings about this. So, so, yes, I think that we can have other
First,
binder
what is
material.
raw meal? For me, a raw meal is like a meal that is not cooked. What does it
Yeah.
mean?
Yeah, okay, good point. Raw meal is it's like the sort of like the feedstock material that you would use to make the cement itself. So to make the cement, you're getting materials from quarries like limestone, clay, even like quartz, sand, and you're putting all this together in a really high temperature kiln to make the cement clinker that then gets ground to make the cement powder you're familiar with. So I think they're really asking about, the feedstock for the cement production itself. And
Mhm.
so I think they're getting at that question of, will we be kind of stuck with the limestone stuff forever? Um, I think to a degree, yes, we'll be stuck with limestone forever. And the reason is because we need materials that can bind in concrete, but also that are really abundant and not expensive. And that pretty much leads us to limestone. I think we can get more efficient with it. And there's really cool technology coming out right now that is looking at processing things differently. So instead of having the conventional method where you're heating in a kiln, um,
Hmm.
and releasing that CO2, people are looking at different sort of like electrolysis kind of synthesis of the materials that circumvents the release of CO2. People are looking at carbon capture of the CO2, but I think it's going to be hard to get around using limestone, at least to replace all of the cement that we use. We could probably get to alternative binders that replace a portion of the cement, but I don't think we'll ever get away from limestone based cements to replace all of the cement that we use. It's just, we require too many.
Okay. Another question is related to when you showed different type of like the classic cement versus the new one that you've been developing,
Mhm.
where they said how that different color and finish would impact the function of the concrete.
Right, is it hot?
Yeah, because especially with global warming and like this, what's the impact of this coloring, darker coloring to attract more heat? And
Yeah.
is there any like functionality of it?
Okay. So most concrete you never see. It's underground. So most concrete, it's not a problem at all. It's, interior, it's covered by other cladding. Um, there's also, like pavement concrete, but if you think about asphalt, most of the roadways, at least we have in the US, is asphalt, which is already black. So that's kind of, typical. So if you think about those two applications, it's, nothing that won't impact it at all. But of course, there are some applications you can imagine where you wouldn't want black concrete. And under those circumstances, you'd either want to, paint it to reduce that, um, to reduce any heating effects. Or you could use it, you could take advantage of it for, passive radiation for like heating water for your home or something like that. So I think there's ways to get around it. Again, most applications, I don't think it's problematic. Zombie. um,
Did
most
someone
applications,
take my sword, by the way?
I
I
don't
Okay.
know.
died and I might have picked yours up thinking it was
Yeah,
mine.
I saw you take it and I was like, where's my sword? Now I have no sword. So, Bob, will you magic me up a sword?
Wait, here's
Yeah,
one.
let me
Here's
just
one.
kill this
I think
guy.
this is all the stuff that was mine when I died. The sword has
Oh,
not
there's
been
one laying
used.
out here.
I
Okay.
died too. I was trying to find it.
Oh, well, it's
Um,
probably.
I'm about to die. Oi.
I'm going back into the house and hiding so I can talk.
So, where were you saying before? Did zombie kill you or try to kill you?
Oi!
I think
Oh,
we flew
Stop!
away from the house.
oh,
Oh,
Oh no.
shoot.
Oh
um,
boy.
oh goodness. Iman, I would love to answer your question. Um, all right, tell me your question again. Oh, I'm dead again. No, I've totally
Okay,
forgotten
so
your question, Iman. I'm sorry.
it's okay, it's okay. So let me roll to another question. So someone said adding biochar to cement is still fundamentally creating a new material, which doesn't have historical data support, isn't it?
Yeah. Yeah, no, it's a great question. I think that's going to be a challenge that we need to ensure that we're not causing any harm to the concrete that's going to affect, for example, its long-term performance. Because if we're affecting that, then it's pointless, right? If we have to replace the concrete more frequently, that's going to be much worse for the
Yeah.
environment. I'll say a couple of things to that. One, replacing a portion of the cement with a material like a supplementary cementitious material like fly ash or slag, that has historically been done. That's something that the industry has a lot more comfort and familiarity around rather than replacing the cement binder itself. but it's true. It's still a new sort of composite, and that's one of the things that we're really focused on right now is doing that durability testing, getting really confident with how it's working so that we can anticipate any kind of adverse behaviors. We don't want to just measure the performance. We really want to understand um, exactly how it's affecting the performance so that we can anticipate any sort of adverse effects. Right now, under the right formulations for the
Sorry, so you're building yourself the data actually that is
yeah,
needed for that.
yes,
Okay.
yep. And then using that data in understanding it, then that's how we can tune the biochar, the biochar to get the properties that we want. Um, so it's this is all trying to think the first paper on this was published in maybe 2013. So it's a really relatively new topic for the concrete industry. I think there's a lot of work we still have to do in understanding fundamentally how it's affecting the concrete. But right now the results are really promising. We've shown that the we can get this similar strength to control samples, and we've done some permeability measurements and found that the depth of water penetration in concrete samples containing biochar is less than conventional concrete, and that's promising as well because it indicates that it should be more durable under most degradation modes. Most of the ways that concrete fails is through water ingress, and so if you can keep the concrete dry and it's low permeability, then that's a decent indicator that it's going to have good long term performance. But we're putting the materials through the gamut right now. I mean, we're doing lots of durability testing. We're working with folks that can help us do more scaled testing, so that it's not just all kind of data living in the laboratory. We're trying to get the data from actual field conditions as well, and to do our due diligence to make sure that we're not coming up with a solution we think is great and actually does more harm. That would be the worst case
Yeah.
scenario for me. I mean, I would never
And
want to do that.
and do you have like a concrete in a concrete way project that use this material already on the ground?
No, not yet. We're identifying folks to do it to do something like that actually as soon as the summer. So yeah, more to come on that. But we hope to cast a real project this summer. It's probably going to be a retaining wall, something that's lower risk and something that has high visibility so we can keep track of it and visually inspect how it's doing, do some testing. Yeah, soon we should have some real data.
Another The chat is really excited about this topic. So I'm just reading. Yeah, that's great. Is there a large overhead for a company creating the biochart? So I missed some discussion, so the person is saying, but I do a lot of concrete work in a rural area, I'm guessing. So EPA protected area, and I am sure they would be interested. So they're asking if like EPA would be interested, or and what kind of a lot of yeah. So it's not really a clear question, but what I'm saying is like, is there a large overhead for companies to create this biochart, basically, and the applicability of this process to bigger project or maybe EPA sponsored project because it's like climate change friendly.
Yeah, I think so. And there's well, this is right up Real Good AI's alley, but there's a lot of interest from data centers too, because they obviously can have a massive carbon footprint, and so they're looking to reduce carbon emissions any way they can. And as you can imagine, there's a lot of concrete in these data centers. So I think they're helping move the market forward with a low carbon concrete tech as well. Anything that you can do to offset the carbon footprint from these data centers is going to be helpful because obviously they're a lot of concrete, which is already, as we mentioned, problematic for conventional concrete, and then on top of that, all of the emissions from like the energy consumption. So I think
Okay.
yes, anybody who cares about it impacting the environment is going to be interested in this. Hey, you guys all
Okay,
sounds
more
good.
questions. Is the PSI strength the same or does it increase or decrease by adding the biochar? Also, this guy who's questioning said that you guys have the same last name.
Oh, fun. um, and so the strength is it really depends on the type of biochar. I should mention my university research has had some gotten to the point where we're looking to commercialize now, and so I've started a company that's commercializing this work. And we have found that again, under the right formulations, the right considerations for biochar selection, processing, all of that, that we can get to improvements with strength. And there's a cap at it. So, for example, certain types of biochar, if we're replacing, say, 30% of the cement, we can see strength improvements. And then at 50%, we're maybe getting to strength parity compared to a control. So it really depends on the level you're replacing it. You do reach some sort of cap at which you're going to start seeing strength decreases, and the point at which that happens really strongly depends on the biochar and the processing. So this is a terrible answer, but it depends.
So another one is asking, have stress fractures been observed, exterior or interior of samples?
No, I mean, we test our samples to failure. So obviously in those we're
How
seeing
do you do
cracking.
that? That's a good question. How do you do that?
Yeah,
You just
so I'll show you an example that we would cast them into like cubes or cylinders, and then we have a load frame that puts a load on the samples and keeps applying the load until the sample cracks. And that's really how you measure the compressive strength of the samples.
oh, cool.
Um, and so we haven't noticed any sort of cracking, except the intentional ones we do. Um, so no, we haven't noticed anything like that. Of course, all of our samples are in laboratory environments right now. So I think when you start seeing, for example, shrinkage cracking and things like that, it tends to be more for larger scale projects. So I think that's one of the things that we need to see when we actually
Yeah,
cast something in the
I
field.
like just from what I saw, like frosting is a big problem in concrete materials, right?
For
And
sure. Yeah.
and
That's kind of
how
what I spent my PhD on.
oh great.
What's frosting? It sounds like it should be on a cake.
Yeah.
Cake, but also, okay, so can you explain quickly what is frosting? How can it impact the concrete, and what are the new results that you observed of this new material reacting to frosting?
Yeah, so you're talking about freestyle cycles. So there's two types of freestyle damage. One is internal frost damage, and one is something that we call salt scaling. The salt scaling only happens in the presence of salts, and that's a surface damage. So you'll see it on sidewalks anywhere. You'll get like little chips off the sidewalks if you're in a freestyle environment. And your sidewalks get salted. You'll see it everywhere. There'll be like little pock marks in your concrete.
So it is
Um,
in cold weather you're talking.
Yes, yes, yep. So when you're talking about frost damage, always in cold weather, the areas that get the most freeze thaw cycles are typically the most aggressive. So Colorado, where I live, is a really aggressive freeze thaw cycle. We get lots and lots of freeze thaw cycles each winter. Um, and then, as I mentioned, the internal frost damage basically happens. Concrete typically always has some moisture left in it, either from snow or residual from when the concrete was made. And when the water in the pores freezes, now you're getting ice crystallization in a confined pore, so you have stress develop, and it can cause cracking. It puts the concrete in tension where it's more weak. And so anyway, that's a whole field of study. The biochar concrete stuff, we have only begun testing on this. Um, I can get into a lot more details on frost damage. I'm happy to if that's of interest, but we've only really begun testing it. Like I said, that the concrete is less permeable, so that bodes well for the concrete because water shouldn't get in as easily as conventional concrete. But I think we need to see how that plays out by subjecting it to both laboratory testing and actual field testing.
Interesting. So, talking about testing, so you know, when we graduate at 10 years, almost 10 years ago, that's crazy.
Yeah,
Uh, AI was not a big thing in a way of applying it to science. You know,
yeah,
it was like a science by itself, but we didn't see that many topics where apply AI. Nowadays, 10 years after, I cannot think of any scientific domain where there is no AI application. So material science comes over and over as like this new hot topic for AI, right? Like
yeah.
they are discovering new materials, testing, doing like creating new ones anyway. And like it's cheaper to experiment on that than like doing experiment like concrete experiment. So
I know
um,
when you're in this field long enough, you totally stop using concrete in any other way except
we have to think about a synonym or something that I don't say
I
concrete.
know.
So speaking of that, how did you see, because you have over 10 years experience, how did you see the shift to the machine learning application of in your domain, and how is it used? Do you trust it? Do you feel comfortable using it more and more in your application or testing and domain in research in general? And how do you see it evolving in the future as well?
Yeah, I think it's a really useful tool. I'm seeing there's already some startup companies that have popped up that are really focused on using AI to improve mix design efficiency, for example. So being able to improve cost of mixes and the carbon footprint of the mixes using AI and using all of the mix data that they've collected over time. So I think it's definitely happening in my field as well. Um, for us, we've used it. It was a great tool for us when we were first starting to explore the biochar use in concrete, because it was such a different material than what we've worked with before. Every hypothesis we had on why it improved strength under certain conditions and not in others, every hypothesis we had, we disproved. And we got to the point where we didn't even know what else to explore. We were kind of out of questions, out of hypotheses. We just really didn't understand what we weren't asking. And so for us, we use machine learning in collaboration with another group to help us understand what questions we should be asking and what other variables we should be curious about. Um, I think I think you have to be careful with it, with over interpreting the tool. So for example, you need a ton and ton of data for it to actually be predictive. And I think that's something that I've seen people kind of overestimate, and the predictability of the sample and or the model on a relatively small data set. Especially as a academic researcher, most of the time our data sets just aren't big enough to have a really robust model. And so, you have to, I think, understand the limitations of the model for the application. So for us, at the time we were using it, we were really using it to understand what we need to be curious about. I think that's a great application for a small data set. What's the data pointing to? Use this to help us understand connections that we're not seeing. But I think for us to use it to be predictive would be a mistake, for what we had. So I think it's very powerful, but you need to understand the limits for the application and your data sets. And I'm really excited to see it pick up more and to be able to take advantage of it as a tool for ourselves as well. We're hoping that we can get to the point where we have enough data for it to be something that's a little bit more predictive and help it to inform what research questions we're asking. So, yeah, I think it's great. I think it's a really great tool. But like any tool, you have to understand how to use it and what its limitations are.
Yeah, so that's what I was going to ask you. Like, do you trust, like, do your researcher, your group trust the results like easily, or what are the guardrail that you're putting in terms of like, does this make sense or not?
So for us, because we're using it to figure out what variables we should be curious about, it's I think it's pretty harmless because basically we
Yeah. Mhm.
use the data, we use the data, formulate new hypotheses that make sense based on like the fundamental science that we understand,
Mhm.
and then we explore those hypotheses experimentally. So for us, it's very low risk. We use it, like I said, to just figure out what we should be curious about, and no more than that. Long term, I would like to use it in other ways, and explore that further, and then I think there needs to be more guardrails. We need to, especially, I think my biggest hesitancy is because I don't personally have a background in machine learning. I don't know all of the questions that I should be asking that I'm not, and I think that's my biggest hesitancy. I think if I were to move forward with this in a way that was more meaningful and something that we had to rely on in more detail, or in more rely on more seriously, that doesn't have all of the checks and balance we currently have, I would need to bring someone on that had more
But
expertise and knew to ask those questions.
but at least it's reassuring to hear that from whatever models that you're using, there is always the experimental part of it that kind
Yes.
of validate whatever the findings are. I
Yes.
see. I see. So I have some other questions from the chat. Thank you for sending all these questions. Is self-healing concrete a good breakthrough? What is the self-healing concrete? Do you know?
Yeah. I think the self-healing concrete, so the one I'm most familiar with, which is probably what this person is talking about, is this like microbially microbial like healing. So it's basically you have bacteria that's incorporated into the concrete that produces calcium carbonate, which can fill small cracks. I think it's early to know if it's a breakthrough or not, to be honest. I think right now the crack size is limited. How it's incorporated into the concrete is challenging, without affecting the strength, or other long-term properties. Um, the I think some of the bacteria can release ammonia over time, which can be harmful to the concrete. I think it's I think it's preliminary. I think it's a cool topic, and I hope that that can be used to become, a really good solution. But I don't know that I would view it as a breakthrough yet. I think I would view it as
TBD,
an,
to be
an
determined.
exciting frontier to explore. Maybe
I
is how
see. I
yeah.
see. So another question, with rebar degradation in the concrete being a large contribution to failure of concrete, how
Yeah.
does this new material, your biochar slash concrete, does with this interaction with the steel?
Yeah. So rebar corrosion typically happens from chloride ions entering into the concrete, and it makes the area around the rebar a little bit less basic, makes it more neutral, and that's what sort of kicks off the rebar corrosion.
And this rebar thing, is it in construction, like when they build foundations and things like that, where they put the
Yeah,
steel and the concrete?
Yeah, almost all of our concrete is reinforced with steel rebar. And the reason for that is concrete is really, really strong in compression, but a lot weaker in tension. So the rebar provides the tensile properties that we need to
I
get
see.
good, durable concrete. Um, And anyway, so we haven't tested it with rebar yet, but what we do know from other literature that's been published is that biochar tends to scavenge up chloride ions. So that suggests that it might actually help rebar corrosion. We haven't tested if there's any decrease in pH. We haven't explored that yet. So, that could be a potential problem. But if the biochar is taking on the chloride ions, then it shouldn't be an issue for rebar corrosion. Um, and I wonder, I'm kind of curious if rebar is going to be um, around long term. That's another one where people are really exploring lower carbon alternatives that are
Oh,
lighter weight. And so it's really a very specific problem to the rebar itself. But that's another one where, again, finding an alternative that has enough of that material um, and still has the same performance and low cost, I think can also will be a challenge.
that's cool. Um, is the mass lighter than the traditional concrete with the biochar?
No, not from what we've found. Well, the biochar itself is less dense than cement, but it also tends to densify the concrete, and so the combination seems to kind of match the conventional concrete strength. So yeah, there's kind of two competing effects: the lower density of the material, but then the densification of the concrete itself.
Okay, another question
Oh,
from the chat. Wow, they are having it with the concrete. With current environmental trends, if the results of this biochar solution are positive, will the fuel costs also have the possibility to be offset? Will it take us less energy to produce in comparison to what we currently have as a standard?
Not sure I'm totally following on the fuel question. I'm gonna take a guess at what they mean, but I might be wrong. Um, I'm guessing they're talking about the efficiency of
Energy needed, I guess, the energy
to
needed.
produce the biochar itself. Is that your interpretation?
I think like what they mean is like, there is a certain amount of energy that is needed in order to produce. Yeah,
The biochar.
energy cost to produce fuel, electricity, etc.
Um, right. So it's specific to biochar, is that
So if the results of the barrage are positive, they said if you need less energy basically to produce it, are they
Ah,
offset?
okay. So I'm not as knowledgeable about the biochar production side, but what I will say is that the life cycle assessment for producing the biochar is still like distinctly carbon negative, and so even considering the energy that's involved in producing the biochar, it's still very carbon negative. And part of the reason for that is that the pyrolysis process, that thermochemical conversion, is an exothermic reaction. So the reaction kind of feeds itself. So you kind of start the reaction and then it self sustains. So it's a pretty efficient process. And then of course, if you are have a sophisticated pyrolysis unit, then you can also pull off other energy sources like the bio oils and the gas that can be used for other energy applications. So if that's what we're asking, that's how I would answer that. And I apologize if I misunderstood the question.
Yeah, they said that's what they're asking.
Okay,
So
perfect.
another question, like in bigger picture, how would you describe the general excitement for this research? Like, are we like supporting in general this research, and we want to put this like to build better concrete in general, or
Yeah.
there is like a kind of resistance to old school thing? We do the old school thing, and we are not like really open to these innovations.
Yeah, it's really interesting. When I started my PhD, I would have said people are more old school and really resistant to it. But the industry has really shifted over the last 5+ years now. And I'm seeing a lot of people embracing innovation. Of course, it's still a conservative industry for good reason. We want to make sure that we're not doing anything that's going to cause harm to people, right? and concrete is used in a lot of life safety applications. So we need to be cautious, I think appropriately so. But there's a lot of appetite for this. It- one like anecdotal story I can share is I'm chairing the new ASTM committee for biochar use in concrete. And one, the concrete industry approved the formation of this new committee. And two, in our first meeting, it was really well attended, and there were really like no haters in the audience. I mean, there was some good pushback and good questions, but there was no obstinate resistance. And that's been our experience across the board. I mean, people want to make sure it's safe, as they should. But if you're answering their questions and you're showing that you're doing your due diligence to do all this testing, make sure the material does no harm, the industry is open-minded to it for sure.
That's great. Would the makeup of concrete differ depending on the country due to environmental factors such as like weather? So, like how the heat and cold affect the concrete differently, and how what's the like the composition of the concrete will differ from a country to a country, or how is it?
Um, that's a good question. I don't know that much about concrete formulations in other countries. There are, of course, certain things that I can say for sure, like areas with
Yeah,
freestyle
even
cycles.
in the US, like
Yeah.
is the concrete in Alaska the same as in concrete in Arizona? I picked like extreme weathers.
Yeah, no, that's good. I'd say, I mean, even in Arizona, there's some spots that get snow, right? So like anywhere there's freestyle cycles, you're gonna have, for example, air and trained concrete. The concrete's gonna have to meet requirements for freestyle environments. There are there are nuances for sure. There's not that I know of it like anything like drastically different, but there are requirements for different environmental conditions for sure. And those are laid out in ACI codes, so American Concrete Institute codes, for like depending on what environmental conditions you have, your concrete needs to meet this class class of like exposure conditions. Um, so it needs to be able to, survive that. So, yes, there are different classes. I don't anticipate being excluded from any of those classes of concrete. Right now, we're demonstrating, structural grade concrete performance. But I think time will tell. As I mentioned, we're early in our freestyle testing, so we need to assure that depending on how that goes, maybe that would mean we're excluded from that application, for example. But right now, all of the testing is indicating that we're good for any kind of application that conventional concrete's used in.
Bob, are you following her advice and building in concrete or no? What material are you using?
Tech wise, I think we're a little ways off from being able to make concrete quite yet. Um,
What's the material?
accumulating. The house is built out of wood, but right now the main thing I've found is cobblestone, copper, and a tiny amount of iron. Um,
What do we need to make it?
I think the biggest thing that we need. Actually, I don't know if that was even a mod or what. Chat, do you know, is concrete like a normal thing in vanilla Minecraft, or is that a mod specific thing? Because I think there was like a mixer type of deal that you needed in order to. It's normal. Okay. Chat, do you know how that works? It's been a minute. I believe there's a mixer. I believe there's a tool which probably requires us to have a non-trivial amount of iron to produce. It's a block created when concrete powder touches water. Concrete requires pickaxe to be mined. Oh, so it's a type of block. You just mine concrete?
That doesn't sound right.
I don't think that's how that works.
I
I mean, that
object
might
to
be how it
the
works here,
science of
but
Minecraft.
yeah.
Hey, but it would
Yeah,
be carbon neutral.
I'll keep
Yeah.
my block right here.
So we have another question of another material scientist apparently. Water repair is a huge issue in rebar corrosion. Are you aware of any advancement in making rebar obsolete?
So say I missed the first part of the
Water
question.
pen. Water pen is a huge issue in rebar corrosion.
Water penetration. Yeah.
Water penetration, yeah.
Yeah. Um, I'm hearing a ton about fiberglass rebar. This is a little outside of my expertise, so I don't want to speak out of turn. I'm a lot less familiar with like supply chain, and I don't know what the if the supply or the like. I don't know enough about these alternatives to know if it can meet the demand for reinforcement like steel can. Um, but I am hearing a lot of alternatives being discussed more and more with a lot of advantages and no obvious drawbacks except maybe the total supply of it to meet, the supply of all the concrete industry. Um, yeah, I'm sorry, I don't know much more about that topic.
It's okay. That's okay. So, kind of branching out here from that. So, uh, additionally of being a professor at the university, you are also an entrepreneur, and you started a little company called 012.
Yes.
And I would like to know more about it. 12 from carbon, that's what you said before. So,
Yeah.
zero carbon emission, I'm guessing. And can you so introduce the company? Tell us what it does and how it works. Go ahead.
Yeah. Yeah, I would love to. So yeah, 012, zero, it's standing for zero emissions. So the 12 is the atomic weight of carbon. Um, I think I'm breaking a block with an apple right now. That's not going to work. um, Anyway, and yeah, the company is really focused on commercializing my university research. So, based on all of the understanding that we've gotten over the last several years of research, now we're looking to be able to produce biochar, use locally sourced biochar that we modify to get good performance in concrete and maximize the environmental impact we can have. And so, um, right now we are raising funds to build our first commercial facility, um, and at that point we will be able to sell kind of meaningful quantities and actually do some projects. As you can imagine, for concrete, the scaled up version is quite a bit larger than most scaled up versions, because even to do a small project you need a lot of material. So that's kind of our next stage. Yeah.
What would you envision making it more available to like everyday people who want to use concrete for their own project, like personal projects and things like that at some point?
Yeah, we're looking
Like
at
Home Depot?
yeah, we're looking at everything. We are talking to folks who have connections with like bagged product manufacturers.
Yeah.
And so yeah, that would be something we would love to do. It's also just a really cool color. So, if you're looking to make a carbon impact and be able to, show that you've made an impact, I think that could be appealing. Just,
Yeah.
for the story and the messaging, and inspire other people to be thoughtful about that. And it's also just pretty for crafts. So I
Yeah,
think it would be nice to have the homeowners have access to it. We've
that's so
yeah, go ahead.
yeah, so tell us more about like the challenges, because it's kind of like it's not like it's kind of unusual to start from academia and go into like entrepreneurship and like have
Yeah.
that kind of thing. So how was it to kind of like start the startup off the ground, and what were the challenges?
Um, it's really scary. It's just, you're doing something that you have never done before. There's a lot of discomfort with all the unknowns and all the things you don't even know to ask. It's one of those things that, at least for me, I was so unfamiliar that I don't even know what I don't know. And that's just kind of an overwhelming feeling. And that there's a high chance of failure, and that's uncomfortable also.
Mhm.
But it's been also really rewarding. No matter what happens from this, I do feel like it's made me a better researcher, a better communicator, a better proposal writer, because I'm so much more aware of what the industry needs now than I was before as just an academic researcher. I'm talking to people who use the material all the time now, and talking to ready mix producers and contractors, and I've broadened my exposure to the industry so much through this process, um, that it's been really eye opening and like super enriching, I would say. So no matter
Yeah.
what happens with it, it's been really good. I'd also say that Colorado School of Mines has really good entrepreneurial support for faculty. That's something that they've been really intentional about cultivating in the recent years. So I was really encouraged to do this. It wasn't, something I was doing behind the back of the university or anything like that. They were really supportive and
Sure.
encouraging of it.
That's great. That's good. And I have to say, it's rare for me to see a woman working in like a kind of like, material science. I would not say material science is morely men, but like construction, concrete feels like you would
Yeah.
be a minority there.
Oh, 100%. Yeah. Um,
Yeah.
yeah.
What
There's
what
there's many
surprised you
times
there? Yeah. Go
there's
ahead.
many times where I'm in a big room and there's only maybe 1 or 2 other women, out of, 50. Um, but it's also I think it's a really, it's a surprisingly, welcoming community, even given the lack of, like, diversity.
Representation. Yeah.
I have never felt like I was unwelcome or didn't have a seat at the table. It's been really supportive. So yeah,
That's great.
at least in where I interface, it's not been problematic.
That's great.
Yeah, really, really great supporters.
Mandy, do you have some questions you want to ask, or should I continue?
Just continue.
Okay.
I'm just listening.
so, so tell us a little bit about yourself. So, what made you want to study your field of study? Again, this is like a very specialized field,
Yeah.
and you don't learn it in undergrad. I'm not aware of any like material science
No.
undergrad. So tell us more about that and what pushed you to kind of choose that.
Yeah, I feel like my exposure to this, that was like my whole career path was so haphazard. It just like kind of so I I'm gonna even back up to like my undergrad. I
Mhm.
actually started my undergrad as an English major. I
Oh
thought
wow,
maybe
very
I thought
different.
I thought maybe I wanted to go into law.
Mhm.
Mm.
And so I did that for the first year, and I found after first year of classes I got really tired of talking about fictional characters' feelings and decided, maybe STEM is a little bit more for me. I missed my math and science classes from high school. And so I started looking into minors that I could do, that involved some physics. I really liked physics in high school. And when I was exploring that, I realized really what I liked is like the mechanics part of physics. So that brought me into like an engineering path. And then exploring the different engineering disciplines, I think I understood the application of civil engineering more. It was just very obvious what they do. And that was appealing to me. So I decided to do at first a civil engineering minor. And then I liked it so much that I just made it into a major instead. And so, loved my coursework, but then when it came to the field of it, civil engineering and actually doing the work of a civil engineer, I liked that a lot less. So I had a few internships that I didn't love.
Why?
Um,
Why? What made you not liking it?
I I just personally found it boring. I don't know. I think I really liked my
Learning more than applying.
I really liked the classes. I liked learning something new. And then when it came to implementing it, I found it, repetitive and not as much fun, not as much challenge, not the challenge that I enjoyed. Um
So this
And
is
so
end of undergrad. This is after the undergrad. Mhm.
yeah, yep, yeah, so I took a job as actually as a construction estimator for a couple of, I don't know, I think I lasted 9 months, and then, I, thought maybe I wanted to teach it since I loved the courses so much, so I started looking at, PhD programs, and then found the one at Princeton, and I realized all of the research areas that were most attractive to me were really material science interfacing with civil and environmental engineering. And so that was when I got exposed to material science, was really in grad school. And honestly, it was my first time doing research as well, because my undergrad university was an undergrad only university. And so there was no research there. And then once I discovered research, I was hooked because that was you can't get bored. I mean, anytime you get bored, you just research something else and you get to learn all the time. And
But what's from okay, so I understand this engineering part, but from civil engineering to materials science, this is something like different because I
for
did
sure.
engineering, but like material science has some chemistry part of it that like, you have to be hooked in it, right?
Yes. Yes. Yeah. Well, there was a lot of extra learning that I had to do. um, I think I was looking for something that, once you finish your undergrad degree, you're kind of set on a path, right? So I needed to look for something that was still interfacing with civil engineering so that I could get into grad school and not have to redo an undergrad degree. And then the areas that I thought were most interesting for civil engineering research were really material science research. So, for example, my PhD advisor, George Scherer, he was a professor in the civil and environmental engineering department, but his whole research group did material science work. And, like most materials, all material science, I guess, it's an interdisciplinary field, right? You're doing material science, but you always have a field of application. So, your field of application might be chemical engineering, it might be mechanical engineering, it might be civil
It could be
engineering,
machine learning also.
it
There's
could be machine learning. Yeah,
yeah,
exactly.
yeah.
And so my field of application was civil, but then the actual science was material science. So that's how I landed there. It was again sort of haphazard. It was really I just liked the research topic. I thought it was really really interesting that here's this material concrete that we've had around for centuries and there's still so much that we don't understand about it and that was kind of fascinating to me to kind of go deeper into a material and understand why it's complicated and then to try to control it. So yeah, that's
Yeah.
that's kind of how I ended up there.
Interesting. So, what was your favorite class during that time? What was like the favorite part?
Yeah, I think it was my first grad class in material science. I forget what it was called. Maybe it was just Introduction to Material Science. I don't remember, but it was the course George taught. And um, I think that was really eye-opening to me just to understand how I don't know, it's going to sound so redundant, but to understand how materials work, and
Yeah.
to understand what material science is and how much control that gives you over the final performance of materials. It's I think before that I really took for granted that material is what it is. You just if you don't like the performance of this material, you use a different material, and that you get the performance out of that. And it wasn't until this course and my research that I discovered like no, you actually have a high degree of control over the performance of materials. You just have to understand the fundamentals. You have to understand how the process and the structure affect performance, and then once you understand that, you can tune the process and structure to get the performance you want.
But
Um,
my question is like more specific. Like, why concrete? I remember. So you and I went to the same grad school, and we met there for disclosure. So, and I remember George group was all women, and all doing material science, specifically concrete. I remember we were calling you George Angels.
Yeah, he's a man of good taste. What can I say?
Yes, but I was always curious, like concrete in material science, I would not think concrete as like one attractive, like you were always doing some cooking of the cement and stuff. And I remember in the lab, it was a mess everywhere. And anyway, so what attracted you honestly to that?
Um, I don't. It's a really funny question. I mean, I think really what attracted me was just it was a civil engineering application of something that was a lot more fun than the civil engineering design I had been doing. But I think what kept me there, um, I don't. This is gonna sound really weird, and the people who love concrete get it, and then everyone else is just gonna think I'm a huge weirdo. I love the way concrete smells. There's just something I don't know, it, like, reminds me of, like, my childhood playing in the basement. I'm not sure, there's just something, like, nostalgic and, it's like grown-up mud pies, you know?
I'm sure
I
people
don't know,
would.
you're either a kid that played in the mud or you're not, I guess, but if you're a kid that played in the mud, it's like it's grown-up mud pies, like, it's fun, you know? And then interject a lot of fundamental science in it, and now you've got this, like, fun moldable material that you can control for, like, specialized applications. I don't know, it's pretty funny, man.
Yeah, I just I give it to you. That's fine.
It's dirty, you know, it's dirty fun, but it's
Yes,
fun.
it's spread everywhere. And anyway, but that's I understand. It's like your Madeleine of Proust. You know, it's an expression meaning like something that always reminded you your childhood and things like that, and it kind of guides you through your career. Interesting. Yeah.
So do you
Yeah.
spend a lot of time in the lab actually working with the materials, or what's your day-to-day look like?
Now, hardly at all.
But
That was a really hard adjustment for me when I first became a professor because I wanted to be in the lab more and I kept trying and it just, it my work just has shifted. So now I get to train other people who can be in the lab and do the hands-on work. And I spend probably most of my well, it's been shifting a lot since the entrepreneurial activities. I'd say I spend about 50% of my time now on like commercialization activities. So some of it's still like research facing, working with my team to ask research questions that are relevant to the industry. And then a lot of it is like interfacing with potential customers, with potential suppliers. I'm kind of spread in a lot of directions on that 50%. And then my other 50% is, more on the academic side. And I spend, um, with
supervising.
that type of teaching, of course, spend a lot of my time meeting with students. That's probably most of my time is one-on-ones with my researchers. And they're the ones doing the work. Wow, what's the pink blocks now? What are these?
So it's pink because we happen to spawn next to a forest of cherry trees, but this is now a concrete building. I'm doing
Yeah.
the roof right now, but the pink blocks are concrete. I got gravel, I got sand from the beach, I made powder, I laid the powder, and then I poured buckets of water on it, just like in real life, totally how that happens. And it is now, once I finish this roof, it'll be fully concrete.
I know we need some this is a good start, Craig. I mean, Bob. This is we can start here. We
Biochar.
need some black concrete.
Yeah, actually, what dyes black, chat? That's an interesting. I don't actually know what creates the
Oh,
black dye.
am I taking all these blocks?
Black dye is a thing you get from ink sacs. Ah, who wants to go kill a bunch of octopuses?
Squids? Yeah.
Yeah, squids in
Probably
the ocean.
squids. I don't know if octopuses will get you any.
I don't know. Whatever. Who wants to go kill a bunch of animals in the ocean? That sounds difficult.
Yeah. So yeah, a lot of my time is spent mentoring students now, which I enjoy that part. That's one of
Yeah.
the things that was my I don't know, drew me most to academia or things I appreciate most about academia is the collaboration. It's just really fun to solve problems together. Um, and so I really I enjoyed enjoy those meetings. But they take a lot of my time.
Yeah, and I'm glad we picked this construction kind of game. So it fits
Yeah, look, it's
so
so
well.
yeah.
Craig, you might want to get out of the house for a minute. It also requires a little bit of scaffolding. It turns out even in Minecraft, you have to build forms to pour concrete.
So, Lori, as a kind of an inspirational kind of question, how, if someone wants to do the same thing or is interested or inspired by your kind of work, what's the career path? What's the advice that you can give someone who's just starting in undergrad?
Oh, that's a great question. This sounds so cliche, but do what you love. I think that when you love what you do, you are more successful at it because you want to spend the time on it and you want to be excellent at it. It doesn't feel like work to hone the skill. Um, Whoa, what is happening here? Is this the water?
This is yeah, so this is how I get the water on it. It turns it from concrete powder into set
Wow.
concrete.
Oh, wow.
You
I
use the
love that I love that you found a way to make concrete happen for this game. Thank you so much.
Hmm. Had to do it.
so cool.
Oh, it's great.
Now we can't smell it, but
I
Um,
know. Well,
we'll have to imagine.
It probably smells really good. It's dyed pink with cherry blossoms. So
that's hilarious.
now the next step is how to make a biochar concrete.
Yeah, maybe that'll I don't know, Minecraft needs a pyrolysis module maybe.
yeah,
Um
you can make mods. Maybe that's good marketing.
Yeah. Yeah, I think my career path has been like pretty windy. I think I've tried a lot of different things and um I don't know, just it all life has a way of working things out.
For sure.
Yeah, you just it's a path I never would have guessed when I was 18.
Yeah.
Um but it's been really rewarding and a lot of fun. So,
Yeah,
yeah.
no, for sure. And chat, if you have other questions for our friend Lori, please put it there in the chat. You have been really, really interested and hooked on the topic. So I'm
Yeah,
just
so glad.
seeking around. Would new industrial equipment, here's a question for you. Would new industrial equipment be needed to produce this new variant within the production process to get this new dry mix?
For to produce biochar, yes, I mean you'd have to produce the biochar, which requires a pyrolysis unit. We do mill the biochar also. Without milling the biochar, it's pretty porous and so it's fragile inside the concrete.
Mhm.
Um, and so there's an additional milling step. Of course, cement is already milled, so there's ways of attaching to kind of existing processes. But nothing major, at least not right now. I mean, we're still early and we're refining things and, there, I guess, could be a potential where we'd have to add something to our process, but the goal all along my research has always been focused on, doing research with line of sight to application. So we want our research to be as implementable as possible. We don't want any barriers to implementation. So um, that includes you know, process. We don't want to add a bunch of extra processes or a big additional infrastructure demand. We don't want to increase costs significantly or really at all. And then, of course, we never want to increase the carbon footprint. We want to reduce it. So all of any kind of final solution has to have all of that in mind for us to at least feel like we've been successful.
Very cool, very cool. Another question from the chat. What kind of volumes this material be able to produce?
So right now, estimates have biochar production in the U.S. at a million metric tons a year. To put that in context, cement in the US is has a demand of about 100 million metric tons, and so it's a lot less than what we would need. Um, I think that's a good problem to have because it means that we could create a market for biochar that's a lot bigger than what it is right now, and
Mhm.
that would allow us to sequester a lot more carbon. But of course, the industry has to get there. With my startup, we're hoping to partner with existing biochar producers, but if the industry can't or doesn't want to scale to the level that the concrete industry needs, then we'll get into producing the biochar ourselves to be able to meet the demand of the concrete industry.
And it is 100% made in the US, right? You don't import uh,
No.
anything.
No, I think you'd have a really hard time getting that carbon negative benefit if you're importing. So no, we're sourcing everything locally to maximize our
But
carbon.
in general, for the industry in general, like the regular, the original, like the classic concrete, does the US import some materials to make it?
They do they yeah, good question. Most of it is locally sourced. I don't know the percentage. Excuse me, maybe 10%, if I had to guess, maybe 10% of our cement is imported, I think mostly from Turkey. Now, what people say is that it's imported, overseas, and that's a pretty, carbon efficient way of doing it, but I don't know all the details to that. Anyway, most of it's locally sourced, but some of it is imported.
Mhm. I'm just reading from the chat. So, my understanding is that most of the CO2 in concrete comes from heating the limestone and that process overall. I wasn't here at the beginning, so I understand correctly that this material fixes things not because it lessens the amount of CO2 during the process, but instead the material itself takes in more CO2. Are there any fixes for the first half of that?
Um, so,
So it
I think
lessens the amount of CO2 during the process by, but instead the material itself takes in more CO2.
so yes and no. It doesn't necessarily absorb more CO2 after it's made. But biochar sequesters CO2 by not allowing the biomass to decompose and release the CO2.
Mhm.
So really the carbon benefit to the concrete is you can replace a decent amount of the cement with it. So that results in less cement demand, and then you're replacing it with this carbon sequestering material. So it's not taking on more CO2 over time. And can you address the carbon footprint of the cement itself, that the first half of that?
Mhm.
There are people who are looking into it in lots of different ways through different sort of binder materials, through different processing techniques. But right now, what's available at scale in the market is the traditional kind of limestone cement where you're processing the calcium carbonate.
I see. And another question. So ideally, a concrete business would only need to add this pyrolysis unit to the production chain.
Yeah, you could do it like that. There's a lot of I think there's a lot of ways you could implement the technology. You want to be close as possible to the biomass source, because once you convert the biomass to biochar, you reduce the mass and the volume by at least 50%. So you don't want to be transporting the higher volume, higher mass material if you don't have to be. So I think that it's probably more likely that the pyrolysis unit would be co-located with wherever the biomass source is. So it could be, a sawmill. It could be a waste processing plant. It could be, at a farm. So I think that that's probably the best location for implementation, just to reduce the transport burden.
I see. I see. So another question. If, which I wish not upon you, but if you have to rebuild your house,
Yeah.
tomorrow, let's say, would you
Yeah.
use concrete or still keep it only for the foundation and still put wood?
Ooh, good question. I guess it would depend for me how expensive it was. I
Yeah,
don't
that's a good question, actually. Return it to you. How expensive this will be?
I don't know. I mean, I don't know enough about wood construction to know. I don't know how
But
to compare it.
but the concrete material that you are advocating for, is it
Oh,
more
yeah,
or less expensive than the regular concrete?
yeah. So most biochar sources are pricing biochar at higher, significantly higher price points than cement, and that's part of what makes my startup 012 unique. Is that we have found a proprietary way of getting that cost way down, um, and so.
How? By doing what? What's made it how down?
So I can't share too much, but it's basically you have to identify biomass sources that are um, that cost money to dispose of. So any biomass sources where you're paying to dispose of them, the that becomes cost competitive because you save money on the disposal. So that's kind of the mindset behind it. But that's
So
probably I
instead
can't
of buying, yeah, instead of buying it, you're paid to kind of take
take
it
it.
away.
Yeah.
Ah,
Yeah, so
I
that's how it becomes, economical, but we are planning to price it, at similar pricing to cement, so it should not be any additional burden for folks. That's
see.
again, our philosophy is try to make this as easy as possible for the industry to adopt, and, price has to be a consideration for that. Whoa, this
Mhm.
looks awesome, you guys.
Yeah, I was seeing like
I
the
we've got a
concrete
castle
thing.
now.
But
Wow.
regardless of the money expenses of like buying, like building a house with concrete versus wood,
Yeah,
uh, would you build a house in concrete?
I think it depends,
Because it's very rare in the US. I've never seen up to now a residential house in
yeah.
concrete completely. Because in Europe, I only see houses in concrete. Like I
Yeah,
don't really see
interesting.
wood.
So
But
I know I don't I don't know, to be honest. I think, externally, I like the concrete, I like the concrete aesthetic. Interior, I feel like it would maybe be hard to, like, hang anything on the concrete
oh,
wall.
for sure.
I don't know, I'd have to think about the, like, implications of that. I
But
would
it would be
probably
solid. You don't need to find the next wooden beam instead. You know,
yeah, that's true. Yeah, you yeah.
you just
Well, you
put them
probably
all.
still put drywall up, I
Yeah, I
imagine.
guess if you were still gonna install drywall,
Yeah,
and the expense were the same, then yeah, why not? You'd have better thermal insulation, you'd have better structural performance, a lot better durability. You'd be fire resistant. Yeah, why not?
and yeah, you can build a bunker or something in
Yeah,
concrete. For sure.
yeah, that's true.
There is a field, a coming field for it.
Yeah.
I see, I
So,
see.
Bob, if I'm stuck endlessly in a cave, is there any way to get out?
Well,
I'm like swimming in the bottom of a cave somewhere and I can't get up.
um,
Can you break what's above you and scaffold your way up?
I am like super deep. I forget how to check how deep I am, but I went down for like the most of this time we were talking.
um,
Did you find
Where
anything
are you?
good?
I found like a ton of materials, and that's why I don't just want to kill myself so that I'd respawn.
Maybe we can do some testing of material with our professor here.
oh no, I teleported me to
Oh,
you.
hello!
Oh
Now I'm
Wow,
more
now
stuck
we
down
can
here.
figure it out.
Welcome to hell.
no! See ya.
Bye.
Hang on. I'm getting there.
Oh, that's funny.
Um, can you type /TP mice curb? or Craigums, since there's no numbers, and see if you can come up here.
Incorrect permission level.
Uh, Chat, do you know is there a command to TP here? Uh, TP here. Stupid syntax. I'm not a coder.
If only there were some coders here.
Mm. I'm not playing, so don't blame me. Um, I have a couple questions to kind of finish up with. What's your favorite sci-fi or futuristic depiction of AI or any sci-fi show or book? Uh,
Oh, favorite? I don't know. They're all kind of horrifying.
so you're not into sci-fi?
I mean, for AI, I feel like it's always like we've built machines that have killed humanity.
Yes,
I don't know
absolutely.
that I don't know that I like the sci-fi depictions of AI.
Thank
I
you.
did it.
You did
I
it.
did it.
Welcome back.
Thank you.
So, do you use AI in any other application of your life? Of your life,
No.
yeah. Or do you like stay away from it like completely? Like, AI is everywhere. So, like,
Oh,
if you are like in social media, you have like algorithms that track you and stuff like this. Or if you are a big, I don't know, Amazon purchaser or something like this, or if you're like, for example, your kids interact with it, or your student, you let your student use chat gpt or something, or
I
you
use
try to avoid it.
ChatGPT. I
Oh,
use
you
ChatGPT. I do. I use it a ton now. I was kind of resistant to it at first. I don't know. It felt like cheating or something to me.
do.
But then I realized, again, it's a tool. We should use tools. You just use them the right way. And I use it a ton now.
Let me
To
guess, for proposals.
Yeah, yeah, for proposals, and specifically, I would say, I I ask for suggestions on how to rewrite what I'm saying for impact and clarity. That's like always my prompt is like impact and clarity. And sometimes I'll give a prompt to like um reduce word count if I'm above a limit. So I really use it for introductions and conclusions a ton. Saves me so much time. I have used it on occasion for like sensitive emails, where
Mm,
things where like I've written and I'm rereading it. I'm like, oh, that's coming off more abrasive than I mean it to, and
mm,
um, things that would take me a lot of time to like think through and consider like, okay, how should I write that? How What do I need to change to make this sound nicer? Now I can just put it in Chat GPT and give it the prompt and
mm.
it rewrites it. So there's things like that that are just big time savers that I really like. Um,
No, that's good. As you said, as a tool, that's totally fine. It's not like write me a proposal and then we'll wait for the proposal to kind of pop up for sure.
no, and anyway, I don't know if you've I've like prompted it for I use it enough now that it kind of knows my story. It knows like my entrepreneurial activities. It knows my research pretty well, right? And so I've tried to prompt it like, give me an outline for a presentation on this topic. And it's not that great at that kind of thing. Like the open-ended questions. I don't think it does a great job with that. I think that's where like human creativity really comes in helpful, you know?
Mhm, mhm.
Um, but I do think it does a really good job with specific like refinement questions.
Yeah.
That's where I probably use it the most.
Absolutely. Yeah, yeah. Yeah, we had like a stream a couple weeks ago about a professor in University of Minnesota who was using it as a way of teaching in an educational way. Like he
Yeah.
created like a chat GPT version for his class, for his lectures. And then the
Yeah.
student would like use it as a TA kind of teaching assistant.
Yeah, I've heard of that too. I haven't taken advantage of that too much, but I think that's going to be really powerful. One thing that I know I have a colleague that has done, I'll probably do it in the future, is to for example, take student comments in the course evaluations at the end of the year and like bin them in terms of like what's the most um, what kind of comments did I get the most? And also like filter out the inappropriate ones that are just like, you know,
You
you don't
have
want to
the
read.
inappropriate ones?
Yeah, on occasion, amen, on occasion. Um, and so, I think that would be, like, helpful and also less traumatic, because I do like to read the comments and get the feedback and try to make improvements, but,
Yeah.
some of them are, like, more emotional work than it's worth, so having the ability to kind of, process that for me and to highlight. Are you riding? I didn't know you could ride animals in Minecraft.
You need a saddle, right?
Oh, I have so much to learn.
Oh, we hooked you with Minecraft. Now you're going to play it
I
more
know.
and
You
Oh
can
my
make
gosh,
me happy.
I'm riding a donkey. I'm so excited. I don't know how to move it. Can you move it? It just does what it wants. That's okay.
It can't move now.
All right. Well, it's less exciting than I was hoping for, but um,
well,
that's
it's a
fun.
donkey. It doesn't move.
Yeah, that's the wrong
Poor
animal.
animal.
That's funny. How many? Can you ride all the animals?
Uh, there are sort of arbitrary limits, but you can ride a lot of them, or
You
they
can
could be your pet.
you could saddle a
Yeah,
pig.
I think you can ride a pig.
I don't know.
Huh. That's fun.
Seems a little small for that. I don't know. That seems mean.
Yeah. Oh, am I?
Any other questions in mind, Amanda? I kind of like don't have more.
You did great.
So, yeah, well, we can ask Lori if you have a question for us, real good AI, for if you are interested in
Yeah.
joining, we do. And
Um,
founder Amanda to talk more about it if you have a question.
yeah, well, I'm kind of curious, like how could you help someone like me, like a researcher, either on the academic side or the entrepreneurial side? Like do you interface with folks like me, or yeah, maybe like walk me through what you do for applications that I might interface with.
So our I think that your entrepreneurial thing is a little bit different than we normally work with. We have connections to academia and nonprofits
Yeah.
specifically, and so our work that we do with the nonprofits, the general idea is that they uh, need help with numbers, with doing statistical or otherwise data science analyses, and don't have the resources to be able to supply these sort of things, but they're doing really great work in the world. Like, for example, one of our partners is Doorways for Uganda, which we also had on a stream, and they focus on getting uh, access to education to people in Uganda because it's not free like it is here in
Mhm.
the United States. So we work with just like a host of different organizations that all have different strategies, but it's great because we can dig in on data and work on different types of problems. Now, on the research side, we have a team of PhDs who have been doing research their whole careers in in data science methodology specifically, and so we are on the working on building partnerships to other academic type problems where we can put our data science to use in sort of these applications where it matters to the world. um I don't
Very
know
cool.
if that gives it very very much. And so, if you have any research problems that are specific, that would be, need some machine learning help or advice along those lines, that's the sort of thing I think we might be able to help you with the most.
Cool. I have another question too. That I think, especially with the way the world has shifted in like the last 5 or so years, it's seeming more and more important for really like everyone to have some capacity for data science, either understand it enough to ask the right questions, or to interface with someone intelligently, or maybe even do some of the work themselves. So, do you have a recommendation for someone like me who might want to learn a little bit more about it, doesn't necessarily want to, redo any degrees, but get a little bit more informed about it and maybe build some kind of baseline competence?
Yeah, I mean, are you looking for like resources particularly or um
Yeah, resources, or like I don't know if there's like classes, whether free or otherwise, that you'd recommend, or
Right. Okay. So actually, that is a really good question. And because we've only existed as an organization for like 8 months, we don't have that yet, but it is on our list. So our plan is to build out a repository where people we work with can have access to these things that either we've created or we've seen in the wild that curated so that they're like really good resources. And so I do apologize. It is on our list, and we do plan on working on that before the end of the year and getting
oh,
some
great.
resources, but we have not. It has not made it to the top of the list yet.
Yeah, well, I'm glad to hear it. That I think that'll be useful, certainly to me, but I'm sure to many people.
Yeah, but we are also the resource for collaboration and research collaboration also with academia.
Right.
So we can be the resource for now.
Yeah, cool. That's great. That's very helpful.
Yeah, because there actually is a lot out there online, right? So I mean, there are just like dozens and dozens of these. Like, I accidentally opened one once, and I was like, oh, I'll just watch this really quick, and then I realized it was like 20-hour long video, and I was like, oh my gosh, who has time to just sit and watch all of that? Um, even to curate that is like a huge Herculean task, but the problem that we're seeing, I mean, we're sort of, I don't know how much Amen has spoken to you about this, but we're relatively anti the mainstream version of machine learning just because of what you mentioned, where it is so data hungry and it is so computationally expensive. So we advocate more for more statistical like machine learning, which is rarer to and more difficult to find. So we're relatively picky is I guess my summary there, but not that other machine learning can't get you some of the help that you need, and you would be building it likely for like a specific problem on a specific data set, but with a limited data set, it's likely a GP might work better for you than traditional machine learning. And so we'd love to talk to you about that further. And actually, Amen and I have experience doing that directly.
She just disconnected.
Oh, too bad.
Sorry. I
No
lost
problem.
connection.
Is she okay still, Bob?
Yeah.
Okay.
Oh, my console battery is low. Better.
What did I
Turn
just harvest? Pointed dripstone. Man, I haven't played this game in a minute.
it.
Anyway, I was just telling you to say that the type of machine learning Amen and I have done, we've done in material science applications before, and it's been relatively successful with these small amounts of data.
Yes.
Just throwing it out there. So
Oh, great. Yeah, that's great. Um,
So
yeah,
we have examples and like connections to build. But that's great. That's great.
yeah,
Well,
would love to chat more about that. And I think yeah, like we're doing stuff with through collaborations, but I would love to point like my own students to resources. I obviously don't have the expertise, but would love to have my students develop that expertise, especially as it becomes, a more and more critical skill set to have in our world. I mean, it just seems like everyone needs to at least have some sort of like baseline understanding of it, just to know what questions to ask and what the limitations are and things like that.
absolutely. I feel like there's been this long conversation in the math world that hasn't made it to like mainstream about whether statistics should be the like high school capstone as opposed to calculus.
Yeah.
And maybe it's just in addition, like maybe we don't need to transfer it out, but definitely in this world of AI, I don't think that there's a way around having statistics or otherwise AI be an important part of that conversation in their education for everyone.
Yeah.
Okay. So where are we in the game now? Are we?
Well, Craig didn't brag about it. Well, I don't know if it's Craig or Mandy, but someone made a nice little waterfall situation.
It was not me. I was in the mine.
I was assuming that was a Craig creation. Um,
What did you build, Lori?
Man, listen, I tried to talk and build at the same time, and it wasn't working. So
How?
Did you fall in the waterfall?
A little bit.
Uh,
I'll be fine.
so I've been walking around with whatever an apple, I think, for pretty much this entire time. I crafted something. I think I killed a zombie early on.
Well, we
Uh,
have a beautiful pink concrete house, so I'm
I
calling it a win.
Yeah, I was a very happy um bystander in this
yeah.
process.
That's great. That's
Yeah.
so great. You have it all.
How do you That's so fun. You can emote. I think I might need more Minecraft in my life. That's what I've learned.
Well, thank you so much for joining us. It was a very interesting conversation, and chat was super into it. So,
Yeah.
Oh, so
Yeah.
glad. Everyone loves concrete, you know?
Yes.
oh,
Oh,
I'm fine.
it told on you. It told
It's
us.
Craig's fault.
Potentially.
Craig's waterfall is very unsafe. It's pretty
where
cool
is
though.
the waterfall?
Here, come with me. Uh,
So I can also fall from a high place.
well, maybe. Craig, wait, where is it? Do you know how to get down there, Craig?
Uh,
I
down the
lost my place. Oh, it's a oh, I went through the mine. That's how I got down
yeah,
there.
it's down the mine, but you can
If
also
you come
jump.
over here, you could see it.
Oh yeah. Is it my little part of the mine that it poked out at one point?
Down that way, there's a little platform and a waterfall.
Oh.
If you really want to see it up close, you can jump from here down to the water.
Doesn't look safe.
It's totally fine. As long as you land in the water, it's
You don't
100%
die?
safe. No realistic fall damage. As long as you hit water first, totally
Ah,
fine.
good.
Big jump, Lori.
And then we can climb. If you come over here, you can climb up the waterfall and then be up on the platform that Craig did.
Well, this is my first
Just go in
water
and hold
experience.
space, and then you'll swim straight up the waterfall, just like in real life.
I don't want to swim up it.
Just go in the waterfall, hold space, and you probably have to push forward because it will be trying to like
Ah,
push you away, and you'll just
yeah, it
slowly
just
swim
fell
up.
off. I was afraid I was drowning.
And then you can see Craig's platform.
Cool.
Wow, that's fun.
What a good view for the end of the stream.
Yeah, well done, Craig.
Thank you. I had help for
It's
that, but
a pretty cool like canyon we spawned next to. This is a nice area.
yeah, I don't think
It's
I've
a
ever
little
seen anyone
terrifying.
spawn in the top of like two cliffs. It was scary. And Mia helped with this. That's why it looks good and there's railing and it's safe.
That makes sense.
Yeah, it makes more
There we
sense.
go.
That's fun. Well, thank you guys for inviting me to do this. This was fun.
Yeah, thank
Yeah.
you for
We've
all
officially doubled my total Minecraft activity in my life, so that's fun.
Well, and you as we come to the end here, you talked extensively about your startup and everything. Is there anything specifically that you would like to plug at the end as a little call to action, or I don't know, anything related to your department or your students or whatever? Anything you want to plug?
Yeah, I guess check out 012, and if you want to get involved in what we're doing or you have any connections or applications that you think are of interest, we would love to partner with you. So, yeah.
Cool.
Yep.
Chat as usual. Thank you from Real Good for being here. Make sure you follow Real Good AI on Twitch, twitch.tv/Real Good AI. We're gonna raid over there for my stream. Anyway, so if you want to follow and you don't want to go anywhere, just wait and it'll go automatically. Make sure you sign up for the newsletter. There is a newsletter and it will keep you connected and up to date. You can also follow the socials. We post multiple times a week on socials, interesting videos, videos about the AI industry, videos about our nonprofit partners, people we're working with. Um, Check out all of the links there in chat, including the link to 012. And thank you so much, Lori, for your time. This was fun. I know we had a off stream before you guys were here, chat. We had quite the battle with technology, but we eventually all got into Minecraft, and uh, this was nice. And we built a concrete structure. So,
Yeah, the pink concrete structure. Love it.
Yeah.
but yeah, I'm gonna start the raid, and Lori, you we'll probably turn your camera off or whatever on stream, but we just to try and build followers on the Real Good channel. We usually do this. If you want to hang around, we can hang around and debrief. But this is sort of the official end of the stream here. Um,
Wonderful.
totally up to you. We want to respect your time. I know this is
Yeah,
this is probably
thank
not
you
the
so
most important thing you have going on.
It was definitely the most fun, though.
You don't have a
Yeah,
lot of
thank you.
Minecraft and the rest of your scheduled stuff for today.
I don't, but I think I'm gonna have to build some in. This was a lot more fun than I realized it could be, so
Cool. Well,
thank you
on
so
my
much.
stream, follow the raid and click the links, and then we're gonna hang out. And it's just been more casual for a minute on the Real Good stream. So goodbye, chat. But make sure you come and follow. Okay. Okay. Bye.